Hello everybody and welcome back to another video. So in this video we'll be learning about Unicode text bytes in Python. So without a doubt, let's get directly into today's YouTube video. Alright guys, so first of all let's talk about what is a Unicode. So a Unicode is a standard for representing text in different writing systems, encompassing a wide range of characters from different languages and symbol sets. Each character in code is represented by unique code points, such as this character for the letter A. So for us, we have the letter A, right? So we understand this. But for the computer or the Unicode, this is how we represent the letter A. So for letter B, it would be something else, like U plus something else, right? So in summary, what this is that it represents each letter, but in its own format, in its own type of way that it understands. So for C, it would be something else. For D, it would be something else. So we'll get into more depth of this topic as we move on for today's video. Okay, so let's move on. So now let's talk about bytes. So bytes are the basic unit of data storage. In computing, represented data as sequence of 8-bit units. So as we all know that a letter, let's take for example the letter A. So it can be represented as bytes. So what a bit unit is that it's zero or one. So for the letter A, we go we could it's something like 0000001, and the text data, which is basically the Unicode, it must be encoded into bytes to be stored or transmitted. So this Unicode, let's just say we have some text like hello, so it must be converted or encoded into bytes to be stored or transmitted. Okay, so that's what bytes are. So now let's move on to encoding and decoding. So now you guys probably didn't understand what encoded was over here, so you will. So to convert text between Unicode and bytes, we use encoding and decoding processes. So encoding, converting a Unicode string. So Unicode is like just any normal string. So we are converting it into a sequence of bytes using a specific character. So these characters could be UTF-8, UTF-16. So this is encoding. So yeah, converting a Unicode string into a sequence of bytes using a character, and that character could be anything, for example, UTF-8, UTF-16, UTF-32, and so on. So now let's talk about decoding. Decoding is converting a sequence of bytes. It's basically the opposite of encoding, converting a sequence of bytes back into a Unicode string using the same encoding. So in encoding, we convert a Unicode string into a sequence of bytes, but in decoding, we convert a sequence of bytes back into a Unicode string using the same encoding process. So in my code editor, I have a encoding.py file. I'll put the link in the comments to my GitHub for this. So we have text over here, hello world. So now we're encoding this text. So this is just a variable called encoded text, and what this is text.encode. We're encoding this to using this character, right? So we could use multiple characters, right? As I mentioned, UTF-8, UTF-16. For this one, we're using UTF-8, and it's gonna print the encoded text. So if I run this, as you can see, it says B hello world. But why is there a B over here? Because this has been converted into sequence of bytes. So this B stands for bytes, okay? And now let's move on to decoding. So first of all, for decoding, we need some encoded text. So let's say we have this encoded text, B bytes hello world. So now we're gonna decoded text will be encoded text. Um if we're converting this encoded text in, and we're decoding it using this character. So now the output will be just normal hello world. So as a Unicode string, Unicode is just like a normal string, right? So that's why it's a normal string. And yeah, we're converting this sequence of bytes back into a normal string. Okay, so now let's move on. Common encoding. So now this talks about all the characters. This actually talks about the most common used characters instead of all the characters. But yeah, so UTF-8, the one we just used. So this has a variable length of encoding 1 to 4 bytes per character. So for the letter A, it uses like 1 byte, but we could use like 1 to 4 bytes, compatible with this ASCII, widely used due to its efficiency and compatibility. So this character is used due to its efficiency and its compatibility. So now for this character, this is 2 to 4 bytes. It's used in Windows and Java environments. And for this character, it's 4 bytes per character, simple but space inefficient. So that's why we normally don't use this UTF-32. We try to stick with these two. So now I'll talk about character issues and solutions. So when handling text data, various character issues can arise due to encoding mismatches or incorrect handling of byte sequences. So and let's talk about an issue called the encoding mismatch. So when text is encoded with one encoding, but it is decoded with another, it can result to incorrect characters or errors. So I have a file here. So we have this text. So we encoded this text. Now what we're doing is we are finding we're able to decode text, and we're converting this encoded text. We're decoding it into using this character. So now this could get us into some errors or unwanted characters. So the solution is to use decoded text, encoded text. We have to use this character instead of this character. So this is the solution. So let's go back to the slides. So byte sequences with incomplete characters. So when processing streams of bytes, incomplete characters at the end of a chunk can cause decoding errors. So I have a file here. So we have this um, byte chunk, but this byte chunk is incomplete for this letter. So it's incomplete, okay? So that's why this could lead us to some incomplete character error. So I also have the solution. I wrote down the solution. So buffer incomplete byte sequence and decode them once. We got to decode them once. The complete sequence is available. So that's the solution. Let's move on. Okay, non-UTF-8 encoding. Some systems may use non-UTF-8 encodings, leading to compatibility issues. So for this issue 3, we are gonna be, we're not using the correct encoding for both encoding and decoding, right? So the solution is to use the correct encoding for both encoding and the decoding. So normalization. The Unicode characters can have multiple representations. Example, this letter E can be represented as a single character or a combination of E and accent. So this is like a different letter with like a little tick over there. So this could also be represented as a combination of this and an accent. So now let's talk about how Unicode bytes can be used in practical applications. So in web development, ensuring text data is correctly encoded, decoded between the client and the server. So this is very important if we have like a little application. And next we can use it to write text files and in the correct encoding to avoid data corruption. So for this Unicode 2 file, so what I just have this text here. So hello and some Chinese text. I just got this from Google. So what this is gonna do is it's gonna open the file called example.txt using this character, and it's gonna write this text in that example.txt file. So if I run this program, so as you can see, it creates the example.txt file with this. So, and now, if I go into my Unicode from file, so what this will do is it's going to open the example.txt using this character, and it's going to read it. It's going to read it, and then it's going to print out whatever it gets from this example.txt file. So if I do that, and now, as you can see, it prints out whatever it gets from this file. So this is how we can use encoding and decoding in practical applications to fetch data from files, or to create a file with specific data. So yeah, I think this is pretty much it for this video. So I'll keep the link for this Google Slides in the comments, and also keep it for the GitHub repository in the comments. So yeah, thank you guys very much for watching. Like the video if it was good. Subscribe if you haven't, and I'll see you guys in another YouTube video.